Okay, I want to review a concern with a test procedure that I have in my book, and it's called signal circuit integrity testing. And this is in section 10. And what we talked about this morning was, what do you do when you have a, say, throttle position sensor, which is a potentiometer, and it is fixed at 0 volts? Do you have a bad sensor? Most likely, do you have potentially a short to ground in the signal wire? Of course, this is a procedure you would do after following your 5-volt reference check and checking your ground, sensor ground, and make sure those are good. And so I want to show you a better way to do this than what I have listed. And what we're doing is, this is actually a working TPS, so I'll show you that real quick. Just have a voltmeter connected and have a T-pin in the signal wire. You see I'm reading 0.37 of a volt. As I open the throttle, my voltage is increasing and decreasing with throttle movement. So it's working fine. Now, if this was a dead sensor, one of the things that I'm telling you to do is to unplug it and to recheck your signal voltage. And you see with it unplugged, we basically have very, very low voltage on this circuit. It's not 5 volts. Some of these circuits will have 5 volts when you unplug it, which would tell you in itself that that circuit integrity is good. So again, the scenario would be you have a sensor that's fixed at 0. You've checked your reference, checked your ground. You're ready to call the sensor. Let's make sure the signal wire integrity is good. You unplug the sensor at this point and you read 5 volts on this wire, you're done. You don't need to go any further. With this sensor unplugged, as long as I'm not touching it, I'm actually sending some voltage through my body here. With the sensor unplugged, you see we have 0.02 of a volt. There's no voltage on that wire. So the test procedure that I've told you to do is to take a jumper wire, or you can actually use a paper clip or whatever you might have, and take the 5-volt reference, which in our case is our middle wire, and jump it to the signal wire and watch your scan data. So I want to show you that. And I have the scanner connected, and we're going to watch this, the top right of the screen here. Actually, maybe I'll blow this up so we can see everything all at once. And what we're going to do is we're going to take this circuit and we're going to do that test. Now I'm going to use 2 T-pins on the back side just because that's what I have right now. So this middle pin is my reference wire. I'll show you that on the voltmeter. And this is not something that you would really want to do, is double T-pin a connector. I'm doing it for testing to show you here. The middle pin, you see I got 5 volts. Is that showing up okay on the camera?
Yes.
Alright, so I got 5 volts on my reference, and then this is my signal wire. We confirmed that with the sensor plugged in. And what I essentially taught you to do was to take that circuit, and then what you're going to do is short these together. So I'm just touching the 2 T-pins together. And if you look at the scan tool, when I do that, does that show up on the screen okay, that line? You see it go to 5? That my scan tool is now reading 5 volts, and what that tells you is your signal wire from the sensor to the computer is good. There's no problems with it at all. I have one problem with that test. And the one problem I have with that test is if the signal wire is shorted to ground, and the reason we're doing this test in the first place is to make sure the signal wire is okay before we put a sensor in the car. But if the signal wire is shorted to ground, what you will do in this test is you will short the 5-volt reference to ground. And that is not a good thing. We don't want to do that. So I want to show you a safer method, and that's going to be to use a 5,000 ohm resistor. So we're going to take this resistor, and you can get these at Radio Shack. The reason I chose a 5,000 ohm resistor is this is the typical resistance of a potentiometer in a car. And so if you think about the circuit design, the computer is going to send 5 volts on one side of the resistor, which is in this case your throttle position sensor, and the other side of that resistor is going to actually be your sensor ground, so it's going to go to ground. So you have 5 volts going through a resistor on its way to ground. We're going to use this as a protection for this condition. And so what I'm going to do is the same test, but I'm going to use the resistor instead. So I'm going to take this resistor, and I'll just take these T-pins out. And on the front side, we good? Take the resistor, and I'm going to go from the reference wire, which is the middle pin, to the signal wire. And we're going to watch the scan tool when I do this. So I'm jumping the reference to the signal using a 5,000 ohm resistor. And you can see in the picture that our scan tool still jumps up to almost 5 volts. This is a safer method because if the signal wire was shorted to ground, it would simply pull this voltage to ground, but it wouldn't pull the 5 volt reference to ground. That resistor is going to act as a buffer. And I want to show you that. So you can see on the scan tool that we still have near 5 volts. What's that number? 4 point what?
98.
4.98. With the resistor in place, it was 4.98 with the 2 T-pins. Now you might be thinking, well, isn't that resistor causing a voltage drop? And it's not, because we're just going into the sensing circuit. There's no ground there, so no voltage drop across this resistor. The resistor is a buffer in case the signal wire is shorted to ground. All right, so this side, this is my reference wire. You see my voltmeter in the picture. This should be, get a better connection here. That should be 5 volts. Can we see that? 5, that's my reference wire. And my signal wire right now with this jumped, hold this here, 4.99. 5 volts on the reference, 4.99 on the signal. So my signal wire, again, we're doing this as an integrity test. Now if this signal wire was shorted to ground, I want to show you that. Get my jumper wire here, and we'll create a short to ground in the signal wire. And I want to show you that this 5 volt reference circuit will still be protected using this resistor instead of a jumper wire. So I'm using a jumper wire to ground. Let's get a better connection here with my test. Okay, so again, there's my 5 volt reference wire. There's my sensor signal wire. As you can see on the scan tool, we have a flat line 5 volts. That would tell you, if you did this test, that would tell you the integrity of the circuit's good. You're done, put a sensor in it. Still having some connection issues here, I'll hold it. All right, so I'm going to simulate what a short to ground in the signal wire would do. The signal wire's to the right. I have a jumper wire connected. I'm going to short this signal out. The signal is shorted to ground. You can see on the scan tool that we're reading 0 volts. This would be a fail for the test. If you did this procedure and on the scan tool you read 0 volts, you have a short to ground in your signal wire. The nice thing about the resistor being here is if we check it, my 5 volt reference wire, which is my middle wire, I'm going to touch this, you see on my voltmeter, I'm still maintaining 5 volts. So what I don't want you guys to ever do is directly short out a 5 volt reference circuit. And so what I'm showing you is the resistor in this case is our buffer. In case this signal wire shorted to ground, we'll still maintain this 5 volts on this reference wire. There's my reference voltage. You see on the scan tool we're at 0. Here's my signal voltage at 0. That is a safer method than using a jumper wire, and so we need to make a few modifications to the book. We're going to go to the board next. Okay, you guys that have my book, I want you to make these modifications. The first one is section 10, signal circuit integrity. Very minor correction, and I will be updating this soon, but for now I want you guys to change this. And on page 3, what I have, circuit high trouble code, circuit low trouble code. This would be an older car using diagnostic trouble codes instead of data stream like I just showed you on this other car. For our circuit low trouble code, when we would be concerned, what we would be concerned about with a circuit low code is a short to ground in the signal wire, potentially an open in the signal wire too, depending on where you're measuring. Circuit low, short to ground, or a faulty sensor. And so what we want to do, disconnect the sensor, jump the 5 volt reference to the signal wire. That all holds true. I just want you to add this right here. using a 5K ohm resistor. Add that. That's just our added protection because of our signal wire shorted to ground. We don't want to pull this reference wire to ground. Next page. Page 4. Same thing. Using scan data, and this is the one I just showed you. A couple of the methods, what we're going to do, step 2, step 3. Step 2 states jump the 5 volt reference to the signal wire using, again, here's your addition, using a 5K ohm resistor. Okay? And of course, that step isn't needed on the designs that use this internal resistor. If you have a signal fixed at 0 and you unplug the sensor and it jumps to 5, you're done. No reason to even do this test. But if we have a signal fixed at 0 and we unplug the sensor and it's still at 0, that doesn't tell you about the circuit integrity, and we want to make sure the signal wire is good. So we're going to take our own resistor and run it between the reference and the signal wire. And again, what that's going to do, you have a steady 5 coming this way, and we're not really going to have a voltage drop here because this sensing circuit doesn't support flow, so we're going to have 5 on this side too. If you have a scan tool connected, we were looking at our TPS, you want to see your TPS voltage go to 5. And that tells you that the integrity of this signal wire is good. And that's the whole point of the test. Now, what I was trying to avoid is if you were doing this procedure and this signal wire was actually shorted to ground and we were using a jumper wire to do this test, what we would essentially be doing is shorting out this 5 volt regulator. Now these are heavily protected and you would be okay. You wouldn't smoke the computer, but what would happen is everything would shut down. Your scan tool would shut down. You'd probably hear some relays clicking and pretty much some bad stuff. We don't want to short this regulator out. And so with our resistor in place, if we have the circuit sorted out like I showed you, I manually did it, what this resistor is going to do is provide that buffer. And so we'll have a voltage drop here that our signal will actually drop to 0 because of our ground, but this will stay at 5. This resistor will act as a buffer. Is 5,000 ohms enough? The reason I picked 5,000 ohms is your typical thermistor, your typical potentiometer is 5,000 ohms. And so if you look at the circuit in its normal state, what's going on here, so let's say this is plugged in, what's going on is you're sending 5 volts across a fixed resistor of around 5,000 ohms directly to ground. And so we've just kind of created the same scenario with our resistor, and it's just a safety measure that needs to be in place. Okay? One other modification, so that's it. Section 10, we're good with those 2 mods. So that was this one on page 4, and that one on page 3. And one other modification. Let's go to section 7, potentiometers. And this is going to be on page 8. And so we're doing the same thing. This is kind of redundant information here on this part, but if we have signal fixed at 0 volts, what are we going to do? Unplug the TPS. Of course, some will read 5, depends on that internal resistor. So here's that picture again. Not all of them have this resistor inside. If it has the resistor, simply unplugging the circuit, it going to 5 tells you your circuit integrity is good. Systems that don't have that, what we're going to do, we're going to jump these 2, but again, we're going to use a resistor of 5,000 ohms. Watch our scan tool change to 5 volts. Tells you your integrity is good. And so what we're doing here, one more change I want you guys to make right here. If it reads 0, jump the 5 volt reference wire to the signal wire using a 5,000 ohm resistor. And it's just simply added protection if the circuit is shorted to ground. Jump back to this picture to emphasize that one more time to make that clear, because I know what some of you are thinking. If I put 5,000 ohms of resistance between here and here, this source is 5. Wouldn't this voltage in here be lower than 5? And the answer is no, because this is just a voltmeter. This is your positive lead, negative lead. There's no current flow through here. So you're putting pressure through a resistor. There's no pressure loss because there's no current flow in this circuit. So this is going to read 5. It will work exactly like a jumper wire works. The only difference, we're better protected.